Today we're going to look at complex numbers. So this is working with when you are taking a square root of a negative. So we have imaginary units. So we're getting into the non-real number system here. So the imaginary unit is if I'm taking the square root of -1. So I'm taking the square root of a negative. That is equal to I. I is an imaginary unit. Also, I squared is equal to -1. So there's just some things you want to know about I and working with I, the imaginary unit, and how it affects the radicals. So let's just go through some examples. So if we're looking at writing an I notation, number one, square root of -49. So we have this negative on the inside of the radical here. So I'm going to pull out an I, because what I can think about this is I can think of this as -1 times 49. So really I'm taking the square root of -1 times the square root of 49, which we just talked about. Square root of -1 is just I. So I'm pulling out an I. Square root of 49 is 7, so I'll have 7I. Or number two, we have the square root of -7. So same thing. You can't, this is probably going to be the last time I do this, but you could write this as -1 times 7. So if I'm taking the square root of -1 times the square root of 7, square root of -1 is I, and then the square root of 7 is just the square root of 7. I can't do anything with the square root of 7, so I just leave it as I root 7. Number three, negative times the square root of -24. So a couple things here. We have -1 on the outside, so this is like -1 times the square root of -1 times 24. I could pull out I for the fact that we have that square root of -1, so I could pull out I from there. So I'm going to have -1 times I on the outside, and then we still have that square root of 24. Square root of 24, we can simplify that down because 4 times 6 is 24. Square root of 4 is 2. And then the square root of 6 I just leave in. So the 2 is going to bump out. Then I have -1 times I times 2, so that's just going to be -2. -1 times 2 is -2. So I'll have -2 I square root of 6. So that process again. I rewrote -24 as -1 times 24. 24 is 4 times 6. The square root of 4 is 2. So we get 2 root 6. Well, I have this negative on the outside, so I'm multiplying that by -1. And then I bumped out I because of the fact that we're taking the square root of a negative. So -1 times 2 is -2, and then times I is -2I. And then we still have that square root of 6. So that's the process here. That's what you want to be doing with I and square root of negatives. So number 4, and also just kind of know these facts here, I squared is -1. So number 4, we have square root of -2 times the square root of -5. What you should do first, though, is take out I for both of these negatives. So I root 2 times I square root of 5. So I'm just bumping out I, so then I have just the 2 and the 5. Because we want to do I times I to get I squared, which we just talked about here. I squared is -1. So then that's going to be -1 square root 2 times 5 is 10. So we get -1 root 10, or just negative square root of 10. Doesn't matter. Each one is exactly the same thing. But you can't just do, I know you might think like, well, if they're underneath the radical, I thought we just multiply. Like if I had square root of 3 times square root of 5, I would do square root of 15. So why aren't we just doing -2 times -5? It's because they're negative underneath the radical, so we have to account for that by taking out the imaginary unit I. Like it's not the same as just saying, well, it's negative times a negative anyway, because technically, why isn't this erasing? Sorry, I don't know why that wasn't erasing. Because technically, we have -2 times -5. So like if we're thinking about just in the real number system, square root of -2, non-real number, square root of -5, non-real number, so it doesn't equal square root of 10. Like that doesn't work. So that's why we have to account for the non-real number of I, pull those I's out. Number 5, square root of -25. First of all, negative, so I gotta pull out an I. Second of all, square root of 25 is 5, so 5I, times square root of -1, square root of a negative, that's I, and square root of 1 is 1. So then I have 5I times I times I is I squared. I squared is negative 1. So 5 times negative 1 is negative 5. Square root of 12. 12 is 4 times 3. Square root of 4 is 2. So I get 2 square root of 3 times, and then I'm going to pull out I from there. So I square root of 3. 2 times I is 2I times square root of 3 times square root of 3. Square root of 3 times square root of 3 is the same radicals and the same value inside the radical, so that's just 3. So 2I times 3 is 6I. Let's take a look at this division 1. So I just get rid of the negative, take out the negative, so that's just I square root of 48. Over square root of 3. And then we have the square roots for both top and bottom. So let's just put this all over one radical there. So 48 divided by 3. And then I would just do 48 divided by 3, which is 16. So then I have I square root of 16. Square root of 16 is 4. So we get 4I. Very good. Let's move on. So complex numbers. Complex number is a number that could be written in the form of a plus bi. So it's more of just a form where you have that I. And a and b are both real numbers, but then we have that introduction of I. So we want to add or subtract the complex numbers, write the sum or difference in the form of this a plus bi. So we have 3 plus 2i plus negative 5 plus 3i. It's just a plus. It's an addition problem. So the parentheses are just symbolizing that we have this complex number plus this complex number. Just like if you had like a polynomial plus a polynomial, it would be the same kind of concept where you're just adding the like terms. Like the parentheses are really serving no purpose other than indicating this is a term, this is a complex number, this is a complex number. Then you add. So I'm going to combine like terms. 3 plus negative 5 is negative 2. 2i plus 3i is 5i. And that is in the form of a plus bi. Number 9, 4i minus 1 minus I. So here we have to be careful because we have the negative 1 times 1 minus I, or we're subtracting off all of this 1 minus I. So I always like to indicate that this is distributing a negative 1 into there. So this is 4i minus 1, because that's a positive 1, so it becomes negative. This becomes plus I, because negative 1 times I is going to be a positive I. 4i plus 1i is 5i. Write it in this form of a plus bi. So I'm going to write this as negative 1 plus 5i. Negative 1 plus 5i. Not 5i minus 1. You want to make sure it's a plus bi. Number 10, negative 4 minus 5i minus a negative 5. So it's going to be negative 4 minus 5i plus 5. Negative 4 plus 5. 5 minus 4 is 1. So write it in the form 1 minus 5i. So multiplying complex numbers together. So number 11, negative 4i times 3i. So same thing as what we've been talking about with just the operations like radicals. Do the same thing with the operations where we're just going to multiply. So negative 4 times 3 is negative 12. And then we have I times I, which is I squared. What is I squared? I squared is negative 1. So this is negative 12 times a negative 1. Negative 12 times negative 1 is positive 12. Number 12, 2i times 4, 2i times negative I. 2i times 4 is 8i. 2i times negative I is negative 2i squared. Then we have to make sure we're cleaning up everything possible. I squared is negative 1. So this is 8i minus 2 times a negative 1. 8i negative 2 times negative 1 is positive 2. And we want to write it in the form of a plus bi, so I'm just going to flip this around to write it as 2 plus 8i. And 13, we have 3 minus 4i times 2 plus I, so we have a binomial times a binomial scenario here. So I'm going to do 3 times 2, 3 times I, negative 4 times, or negative 4i times 2, negative 4i times I. So 3 times 2 is 6, 3 times I is 3i. Negative 4i times 2 is negative 8i. Negative 4i times I is negative 4i squared. Pay attention to the like terms in the middle, and this I squared can be rewritten as negative 1. You always have to remember that fact that I squared is negative 1, which is then going to generate another pair of like terms after we do this. So let's just write this down. 6 plus 3i minus 8i is negative 5i minus 4 times negative 1, because I squared is negative 1. So that is going to become 6 plus negative 5i, or 6 minus 5i plus 4, and then we get these two terms here. 6 and 4 are then like terms. 6 plus 4 is 10 minus 5i, writing it in the form of a plus bi. There's a lot of things happening on the back half there. 14, 3 minus I squared is going to be 3 minus I times 3 minus I. So we're just multiplying the same thing together. You could use that formula if you want, but you could always just multiply 3 minus I times 3 minus I. It's going to be the same exact thing. So 3 minus I times 3 minus I is 3 times 3. 3 times negative I times 3, negative I times negative I. So 3 times 3 is 9. 3 times negative I is negative 3i. Negative I times 3, negative 3i. Negative I times negative I is positive I squared. I times I is I squared. Like terms in the middle. 9 minus 6i, negative 3 minus 3 is negative 6i. I squared is negative 1. So this is going to become plus negative 1. 9 plus negative 1 is 8. 9 minus 1 is 8. So 8 minus 6i. Getting pretty tricky. Getting pretty tricky. Last one, 8 plus 5i times 8 minus 5i. So these are sum and difference of two complex terms. So you could do a little bit of a shortcut here. Like there is a little bit of like a formula. I really tried to avoid formulas and shortcuts as much as possible, just because it's very specific to certain scenarios, and you might get it confused with like 3 minus I squared. Like, oh, can I use a formula there? Like, there is a little formula there. But I like to just multiply it out. So I'm just going to go the route of multiplying this out, and then we'll see what happens here, and then you can kind of make a connection there. So 8 times 8 is 64. 8 times negative 5i is negative 40i. 5i times 8 is positive 40i. And then 5i times negative 5i is negative 25i squared. In the middle, gone. Like terms, gone. So I get 64 minus 25 times I squared is negative 1. So 64 minus 25 times negative 1 is positive 25. 64 plus 25, I don't want to make a mistake, is 89. So we get 89. Now, there's one thing I forgot to mention here, going back to like number 11. You see how we're trying to write it in the form of a plus bi, and I just get 89? The technicality here would be writing this as 89 plus 0i, like that. Because we don't have like a bi here. We don't have this bi term because everything just drops out. So this would technically be 89 plus 0i in that form. Same thing over here for number 11. 12 plus 0i would be the technicality there. I don't think that like on an exam or something that points should be really taken off for not writing it in that form. I mean, I think if the directions ask for it, but like, I don't know. What I'm trying to address right now is making sure you understand the concept of what the relationship between I squared, and all that, and trying to work all this out. So this is a little bit of a technicality there on the final form. But so technically it should have that plus 0i. But that's not really the goal for the lesson, is making sure you write that 0i. Moving on. Dividing complex numbers. So when we're dividing complex numbers, we want to use the complex conjugate. So when we're rationalizing the denominator, we multiply by the conjugate. Just like if we had like 1 over 2 minus the square root of 3, we'd multiply by 2 plus the square root of 3. You'd multiply by that conjugate. Same exact concept for the i's. If you had a plus bi, you would multiply by a minus bi. Same exact concept. Or if it was a minus bi, you'd multiply by a plus bi. So we are dividing. So on 16, we are going to think of it as rationalizing the denominator. It doesn't say that, it says divide, but that's what we want to do. We want to multiply by the conjugate. So if I have 3 plus I over 1 minus I, I'm going to multiply by 1 plus I. So I'm multiplying by 1 plus I. Let me rewrite that. So on the top, 3 times 1, 3 times I times 1, I times I, then on bottom. We'll talk about that in a second. So 3 times 1 is 3, 3 times I is 3I times 1 is I times I is I squared. On the bottom, 1 times 1 is 1, and then when we multiply by this conjugate, remember that relationship, the middle terms drop out, so I'm not even going to do that. All I have to do is negative I times I, which is negative I squared. And then we have to rewrite quite a few terms here. I have some like terms in the middle. I have some I squareds here. So let's get 3 plus 4I minus 1, because I squared is negative 1, over 1 minus negative 1. I squared is negative 1. So on the top, 3 minus 1 is 2. So 2 plus 4I over 1 minus a negative 1 is positive 2. So check this out. This can now be rewritten again. There's a couple different ways you could do this. So you can factor out a 2 from the top, 2 plus 4. You can factor out 2 because that's going to simplify with 2. You can also just break it up into 2 fractions. I'm going to go the route of just thinking of this as factoring out a 2. So I'm left with 1 plus 2i all over 2. 2's drop out. So then you're left with 1 plus 2i, and that is in the form of a plus bi. Yeah, kind of a funny step there. If I rework this real quick. 2 plus 4i over 2, you could also just break this into 2 fractions, like that. So 2 over 2 is 1, plus 4 over 2 is 2, so you get 1 plus 2i either way. And 17, 2i. So 2i, we're just going to multiply by negative 2i. Kind of a funny concept there. We're just multiplying by the negative 2i. Because if you think about what's happening with that one, like why are we just multiplying by 2i? This is technically 0 plus 2i. If we think about that a plus bi, remember how we were talking about that a second ago on the technicality here of like you would want to write this answer as 89 plus 0i. This is kind of why this comes up, why that's kind of important, because of this. If I have the a plus bi, this is technically 0 plus 2i. So the conjugate would be 0 minus 2i, but we don't need to write that 0 down, so then we just write negative 2i. So on top, 5 times negative 2i is negative 10i, over 2i times negative 2i is negative 4i squared. Negative 10i over negative 4 times negative 1. A lot of negatives being thrown around. So negative 10i over negative 4 times negative 1 is positive 4. Get close to my camera here. Negative 10 over 4 simplifies down to negative 5i over 2. So that would be 0 minus 5i over 2. Again, I'd be okay with that answer. It's just kind of getting technical. Last part of this section is finding powers of I. So this is simplifying I. And if you look at these examples that I have here, like I to the 7th, I to the 24th, I to the 42nd, and so on. And you want to rewrite this into simplest terms, so it's just like I or -1 or something like that. But we have some crazy exponents. So I have a chart here that is a little bit of a guide, but really what you want to know is like pretty much this set right here. Like that's pretty much what you want to know, especially I to the fourth. I to the fourth is really nice because it equals 1. So I to the fourth equals 1. So when you have a number like I to the 42nd, you can use I to the fourth really, really nicely, and it could help you out and break this down into into smaller i's. But I to the fourth is equal to 1. So typically we try to use I to the fourth as much as possible. So number 18 is I to the 7th. And I know we already have the answer here. I to the 7th is -I. But I want to look at this and just like, what if we don't know what I to the 7th is? Because like no one's going to memorize this whole chart. Like there's no use of you like knowing I to the 10th is -1. I to the 6th is like, that's very difficult. That's a lot to memorize. And there's actually a little bit of a pattern if you really pay attention to like every 4. I to the 1st, I to the 5th, so 1 plus 4 is 5, 5 plus 1, and they're all the same thing, i's. Same thing here, 2 plus 4, 6, 6 plus 4, 10, -1, -1. So they're all kind of the same, but it's not something that you would want to commit to memory or really be able to commit to memory if you're really not trying. So I to the 7th, I want to look at this though with 4, so like I was saying with 4. So 4 goes into 7 one time. So I'd have I to the 4th to the 1st. Then, if 4 goes into 7 one time, how many are left over? Think of like mixed fractions and improper fractions, that relationship. 4 goes into 7 once, that's 4. 7 minus 4 is 3. So then that means I'd have an I to the 3rd left over. Because I'd have I to the 4th times I to the 3rd. 4 plus 3 is 7. I to the 4th is 1. So this is 1 to the 1st times I to the 3rd. 1 to the 1st is 1 times I to the 3rd. What is I to the 3rd? I to the 3rd is -I. So my answer is -I. I to the 24th. So think about powers of 4. 4 goes into 24 6 times. So I to the 4th to the 6th, because 6 times 4 is 24. But look, I to the 4th is just 1. So this is 1 to the 6th. And the reason we want to use 4s is because 1 to any power is 1. So 1 to the 6th is just 1. Done. This is all the thought that needed to go into that one. I to the 42nd. So 4 goes into 42. How many times? 10 times. So that's I to the 4th raised to the 10th. And that's going to be how many left over? 4 times 10 is 40. So how do I get to 42? I add 2. So this is I squared now. And if you backtrack it, I to the 4th to the 10th, that's I to the 40 times I to the 2nd, I to the 42nd, because 40 plus 2 is 42. Okay. So then I to the 4th is 1. So this is 1 to the 10th times I squared. 1 to the 10th is 1 times I squared. I squared is -1. So this is 1 times -1, which is -1. And 21, I to the -16. So it's just a negative exponent. So all you're really practicing here is just being able to rewrite it as 1 over I to the 16th, just moving that down to the denominator. And that's the same thing. 4 goes into 16 4 times. So this is 1 over I to the 4th to the 4th. So 1 over I to the 4th is 1 to the 4th, which is 1. So 1 over 1 is 1. Done. So you know your 4s. So I would just make sure you know this first box there, or that first column. That's going to be the most helpful, because that's really, I didn't even use anything else. I mean, you could use other ones, but if you know your 4, those 4, pretty much, then you're good to go.